Hello, algebra students. Mr. Lawrence here, and this will be your second midterm review video. It'll be covering expressions, equations, and inequalities. I know a lot of you have difficulty reading the math, so we're going to go over a couple things that help me read it. Hopefully it'll help you. Now, see this expression right here? It reads 3x plus 4, but if I ask you what it is, you shouldn't be telling me it's 3x plus 4. You should be telling me, well, let's see, x is a number, and I'm multiplying that number by 3. So whatever that number is, I need 3 times that number. Okay, and then I need to increase it by 4, right? That's what the plus 4 is. So this is actually 4 more than a number tripled. Yeah, when I translate it, I go backwards. Okay, well, what does that mean on this one? This means that I'm going to do 5 less. 5 less than what? A number that's being doubled. So this would be 5 less than a number doubled. Now that could be said different ways. You might hear 5 less than twice a number or something like that. But anyway, so let's go down to numbers 1 and 2 and 3 and see if you can write these expressions. Now, if you'd like to pause the video and try to write them, I think that's a great idea. I'm going to go ahead and explain how I do it. First of all, I need a number. I'm going to call my number x. You might call it n. That's fine. I need 5 times the number. So I need 5n or 5x. Okay. I need 3 more than that. Well, that would be adding 3. There you go. There's your expression. I can't tell you what x is because there's no equal sign. I can't solve for x. Not in that situation. Okay, here we go. 7 less than a number doubled. Well, I need a number. I need the number doubled. So that would be 2x. Then I need 7 less than that. Well, that would be take away 7. And there you go. All right, now this one's a little bit longer, and I will be able to solve for it. How do I know? Because there's going to be an equal sign in it. All right, I need a quotient. Quotient is the answer to a division problem. So I need a quotient of what? I'm going to need, this of is telling me I'm going to need, two numbers to divide. If I said the quotient of 8 and 4, well, that would be 8 divided by 4. Okay, so the first number, the first thing that comes will be my numerator. Well, I said the quotient of the quantity. Well, there's going to be a quantity in my numerator. This of is going to tell me what's in the quantity. I need 2 less than a number tripled. So I need a number. I need it tripled. So I'll get 3x, and I need 2 less than that. There's my numerator. Now, the and is going to tell me the other number in my quotient, the denominator. Remember when I said the quotient of 8 and 4, we wrote 8 and 4, 8 divided by 4. So the and tells me the second number is coming up, and that'll be a 7. And let me extend my fraction bar there. And that is 4. Now I'm ready to solve. Okay, remember, some of you would want to add 2 here. You absolutely cannot add 2. You can't do it. It's locked in by the fraction bar and by the quantity. I'm going to get rid of this fraction first of all. I'm going to multiply both sides by 7. When I do that, on the left-hand side, the 7's cancel, leaving me with 3x minus 2. The parentheses at this point are unnecessary because there's no number in front of here besides 1. So I'm going to drop the parentheses out. Excuse me. And that's going to equal 28. 4 times 7. Okay, well now I just have a simple two-step equation. Listening to Saddam. Add 2 to both sides. And I will get 3x equals 30. And I'll divide by 3. Divide by 3. And then x is going to equal 10. All right. Let's get down to some actual equation solving. Again, we're going to listen to Saddam. These are for linear equations. In the video yesterday, we were solving by factoring. That was for quadratic equations, right? Maybe a cubic one was thrown in there as well. So we're going to undo subtraction and addition before we undo division and multiplication. Well, the first step here is going to be to get rid of the 6. Why? Because it's attached by subtraction. So I'm going to add 6 to both sides. And when I do that, my left-hand side becomes 3x. These have canceled, and that equals 24. And then I'm going to divide by 3. I'm going to divide by 3. X is going to equal 8. Now I can check my answer. 3 times 8 minus 6. Well, 3 times 8 is 24. 24 minus 6, sure enough, is 18. There we go. It works. Now, number 5 is one that gives many students trouble, and I think I've got a couple examples of this type coming up. This negative that you see here, it belongs to the 2. So when I stop and ask myself what numbers are attached to x, well, I'm not going to say a 2. I'm going to say a negative 2 by multiplication, right? The 7 is actually a positive 7, which means it's attached by addition, even though you see the subtraction there. And if I would do this, does 7 plus 7 cancel? No, it doesn't. You have to check your work as you go. 7 plus 7 does not cancel, therefore I must subtract 7. Use the inverse operation, excuse me. My 7s will cancel, leaving me a negative 2x equaling 8. And from here I can divide by negative 2. And I'll get x equals negative 4. There's my solution. Of course I can check it. 7 minus 2 times negative 4. Well, this will turn into positive 8. Negative 2 times negative 4. 7 plus 8. 15. It checks. All right. Over here, sometimes our equations has variables on both sides. This is not a big deal. You don't like that there's a variable on both sides. So I'm going to take away 3x from both sides. Okay, I'm going to take it away. I'm going to take away the problem, leaving me 2x minus 8 equals 20 because these cancel. Now, remember I suggested taking away the smaller of the x variables. Many times that'll make things easier for you. You could have taken 5x away from both sides, but taking away the smaller one will usually make your problem a little bit easier to deal with. Okay, so now I'm solving my two-step equation. I'll get 2x, and that's going to equal 28. And then I'm going to divide by 2 on both sides. I'm going to get x equals 14. Now, by the way, I'm getting lots of pretty answers. You don't have to get pretty answers. You can get fractions or decimals, okay? Now I'm going to check my work. I'm going to do 5 times 14. I'm substituting 14 in for x right there. I'm going to take away 8. And I'm going to go over here and do 3 times 14. I'm going to add 20 to it, and I'm going to see if I get the same answer on both sides. So 5 times 14, 70, I think. 70 minus 8, it's going to come out to be 62. 3 times 14, well, let's see, I think that's 42 plus 20, and sure enough, 62. So the answers match. All right. Now here's one where I remember I suggested taking away the smaller of the coefficients. Well, negative 10x is smaller than negative 4x. But to take away a negative, I have to add. So I'm going to add a positive 10x to both sides. When I do that, these have canceled. I get 6x plus 7 equals 7. I'll subtract 7 from both sides. and I will get 6x equals 0. Now, some of you right now are going to stop and go, oh, that can't be done. That's undefined. And no, it is not. It is not undefined, and I will explain in a minute. Okay, let me see. Let me go over here. Please read this problem to yourself, and don't read it as 20 over 4. The acceptable ways to read this are 20/4 or 20 divided by 4. Now I'm going to focus on the division part. So this means 20 divided by 4. That's 5. So you see I'm dividing by the bottom number, the denominator, right? Now I don't get the same thing if I do 4 divided by 20. Many of you think they're the same thing. They are not. 4 divided by 20 would equal 4 divided by 20. And that's going to end up being 1/5. How did I get 1/5? Well, you could have simplified your fraction. Divide by 4 there, divide by 4 there, and you see you get 1/5. But the important part of this is noticing that the number you're dividing by is the denominator. So this is 4 divided by 20. So therefore, this problem is 0 divided by 2. Is there any rule against dividing by 2? No, there's not. You can always divide by 2. If I have nothing and I share it with one other friend, well, then we each get nothing. So 0 divided by 2 is 0. However, the next one, 2 over 0, and again, I said not to read it like that. This problem is actually 2 divided by 0. This is where your warning bells go off. Look, I'm dividing by 0. This is undefined. So it depends what number is in the denominator. If there's a 0 in the denominator, the problem is undefined. But as you see in this case here, 0 is not in the denominator. So I can do this problem. And x equals 0 divided by 6. If 6 friends are sharing $0, each one gets $0. Okay, I'll leave that one for you to check on your own. Okay, number 8 and 9, they're required distribution, although you notice how 3 will go into 33 evenly, and on number 9, 4 goes into 80 evenly. You don't have to distribute these. I'll do one where I do distribute, and I'll do one where I don't. Okay, so on this one, I'm going to go ahead and distribute. I'm going to multiply 3 times the quantity of 5 minus 2x. Notice I'm not adding 2x from both sides. I'm not subtracting 5. That 5 minus 2x is trapped by the quantity because there's just 3 in front. So I'm going to get 15 minus 6x, and that's going to equal 33. And I'm going to subtract 15 from both sides. And I'm going to get negative 6x equals 18, I believe. I'll divide by negative 6, divide by negative 6, and I'll get x equal to negative 3. Okay. If I put negative 3 in here, I get negative 2 times negative 3 is 6. 5 plus 6 is 11. 11 times 3, 33. Just kind of checked it in my head there. Okay, now on this one, since it's 4 times this quantity, and 4 goes into 80 evenly, I'm going to divide by 4 on both sides. And the right-hand side, of course, becomes 20. The left-hand side, the 4's will cancel, leaving me with 8 minus 2x. All right, from here I will subtract 8 from both sides. And I'll get negative 2x equals 12. I'm going to divide by negative 2, divide by negative 2. X is going to equal negative 6. And there you go. All right, checking it. I should go back to the original problem to check. Let's see here. We have 4 times the quantity of 8 minus 2 times negative 6. There's a 6 in there. All right, so inside the quantity, I'm going to have 8 plus 12. 8 plus 12 is 20. 20 times 4 is 80. Boom, it checks. All right, let's do a couple inequalities and we can wrap up this video. Now the inequalities are done the same way as the equations, except we graph our solutions on a number line. So I'm going to get rid of this 5 by subtracting 5 first. Those are going to cancel. I'll have a negative 2x, which is greater than negative 14. I'm going to divide by negative 2. Warning bells should be going off. Whenever you multiply or divide by a negative, your inequality changes direction. Whoa, what is that? It doesn't change shape, it just changes direction. And that'll be 7. All right, so let me see here. I need a number line. Something like that. Put an arrowhead on that end. I need the number 7 if you want to show another number, 0, maybe 10. That's fine. It's going to be an open point at 7 because it's not equal to. And I need numbers less than 7. Well, what number is less than 7? How about 4? So I'm going to shade toward 4, and then that goes forever, because every number less than 7 makes this inequality true. All right, now we have some compound inequalities, and these give some of you trouble. This problem is an and. And is the only one you can write as one long equation. Okay, it's actually an inequality, but one long expression like this. So I'm going to start inside here, and I'm going to get rid of the numbers that are attached to x, and I'm still going to listen to Saddam. So I'm going to add 8 first. The difference is I'm going to add 8 in 3 places. It's really like I'm just doing 2 inequalities at the same time. I'm solving 4 is less than or equal to 2x minus 8, and I'm simultaneously solving 2x minus 8 is less than 16. Okay, I'm going to get 12 less than or equal to 2x, which is less than 24. And I'm going to divide by 2, going to divide by 2, going to divide by 2. 6 is less than or equal to x, which is less than 12. So, get my number line over here. Guess I could change his arrowhead, that way when I clone him next time, I won't have to draw in the arrowhead. And I need the number 6 on here and the number 12. 6 is going to have a closed point. 12 is going to have an open point. And do you notice the x is between 6 and 12? So the solution is all the numbers that are between the 6 and 12. So it looks like that. If I take a number here, fill in the blank, a number like 8 would work very nicely. And 8 would be in the middle here somewhere, right? But if I had a number like 2, 2 would be over here somewhere. It's not a solution. 6 is not less than or equal to 2. Okay, if I picked a number, say like 15, well, 15, 6 is less than or equal to 15, but 15 is not less than 12. This part fails. So I want the numbers that work for both parts, like 9 or 8.5, 10.25. All right, that problem is done. Now, sometimes our ands are written as 2 statements. This gave some of you trouble on a test recently. All I'm going to do is I'm going to solve this part, and then I'm going to solve that part. I'm not going to write it as one statement. I'm going to go minus 2 from both sides. 5x less than 5 divided by 5. X is going to be less than 1. And subtract 6. I'll get negative 2x is less than negative 26. Divide by negative 2. Divide by negative 2. I'm going to get x is greater than 13. y greater than? Well, dividing by a negative caused my inequality to flip. So let's see here. Let me clone him. I'll put 1 on my number line. I'll put 13 on my number line. They'll both be open points. Now I need the numbers that are less than 1 and greater than 13. This problem has no solution to it. Definitely no solution, because you can't find me a number that is less than 1 and greater than 13. It's not going to happen. Now, I actually didn't intend to give you a no solution one there. I have a small typo, but the problem still works. What we're going to do here is we're going to change that to a greater than. Of course, on a test you can't do that, but I'm going to solve it using a greater than. So, is that going to do what I want it to do? Hold on. Okay, so we're going to try to solve these again, so that won't come out to be no solution. I've altered the problem. So again, I subtract 2 from both sides, and I will get 5x is greater than 5. Then I'll divide by 5 on both sides, and I'll get x is greater than 1. Okay, and there's my 1 with an open point. I'll subtract 6, subtract 6. Negative 2x is greater than negative 26. Divide by negative 2, divide by negative 2. X will be less than 13. So we need all the numbers that are greater than 1 and less than 13 at the same time. Well, that'll be in between. Oh, by the way, I forgot my word and. It's very important. Very important. And that is my solution set right there. And that's the picture of my solution. Because if you pick a number like, say, 9, 9 is greater than 1. And 9 is also less than 13. So you see we need both parts. Okay, that doesn't conclude. There's one more problem here that's hiding on me. All right, let's see how this one works out. Okay, I just checked it really quick mentally to make sure it was going to work. Again, I solve it in 2 pieces. Why? Because it's written in 2 pieces. For x is going to be greater than 12. Divide by 4, divide by 4. X will be greater than 3. Over here, I'll subtract 5 from both sides, and I'll get 2x is less than 3. I'll divide by 2, and I'll get x is less than 1.5 or 3/2. There's an or in there. There's my solution. So I need to show 1.5. I need to show 3. Open points for both of them. They're closed points when I have equals in there, right? Like if that were equal, it would be closed. It's not equal, so I won't put it in. I need numbers greater than 3. Well, they are to the right of 3, aren't they? And I need numbers less than 1.5. All those are to the left of 1.5. And that's it. That's all for the video. All right, so we talked about expressions, equations, and inequalities. All right, Mr. Lawrence signing off. Good night, everybody.